Now we continue with related rates multiple choice AP questions. We have 1993 AB 34. The top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. So we have the ladder here leaning up against the wall, but the top part is sliding down the wall. And since it's sliding down, again viewing this as if it were superimposed on an XY coordinate plane, that means that the y values are decreasing, or dy dt would be negative 3 feet per minute. Now what we're trying to solve here for is the rate of change of the distance between the bottom of the ladder and the wall. And that distance is x, but the rate of change of that distance would be dx dt. So we want to find dx dt is equal to what when y is equal to 7. And of course we know that the ladder has a constant length of 25. So we need a formula to relate dx dt and dy dt. And so that would be x squared plus y squared is 25 squared. We're going to differentiate both sides with respect to t. We get 2x dx dt plus 2y dy dt is equal to 0. Our goal is to solve for dx dt, and we can divide through both sides by 2. We plug in y is equal to 7, dy dt is negative 3. That's got to equal 0. This is a Pythagorean triple. So if y is 7 and the hypotenuse is 25, then x would be 24. So we can replace x with 24, and that leaves us with 24 dx dt is equal to 21. Dx dt is 21 over 24, or 7 over 8, and it would be positive because the x value is increasing. So that would be answer D. And we'll pause here for a second and then go on to the next video, to the next problem. Okay, we come to 1993 AB 39. We have the radius of a circle increasing at a non-zero rate. So there's our circle with our radius increasing at a non-zero rate. And at a certain instant, the rate of increase in the area of the circle, would be dA dt, and that is numerically equal to the rate of increase in its circumference. Well, if the circumference is 2 pi r, then the rate of increase in the circumference, dc dt, would be 2 pi dr dt. So we want to use the constraint that dA dt is equal to 2 pi dr dt. So when dA dt is equal to 2 pi dr dt, we want to know what the radius is. So we're going to use an equation that relates dA dt and dr dt, or the area and the radius. That would be a is equal to pi r squared. Differentiate both sides with respect to time, and we get dA dt is equal to 2 pi r dr dt. Now we're looking for the time when dA dt is equal to 2 pi dr dt, and so if we were to rearrange the terms on the right side, we would get that dA dt is equal to 2 pi dr dt times r. And since dA dt is equal to 2 pi dr dt, both of those will cancel, and we'll get that r is equal to 1, or option D. And we'll continue with the next two problems in the next video.